Welcome, welcome. Hi, everyone. Welcome to this session. Today, we're going to share how Major League Baseball creates granular cost insight and application insight with observability analytics. My name is Joy Wang, and I'm a senior product manager of Cloud Observability.
Hi, I'm Rupa Patel. I am a senior product manager. I work on cloud billing, FinOps.
Hi, everyone. I'm Frank Dice, Principal Cloud Architect at Major League Baseball, and I also lead the Cloud Strategy and Optimization team.
So today's agenda, we'll talk about how, MLB's footprint on Google Cloud. And then I will be talking about observability analytics. Rupa will be talking about cloud billing. And then Frank will share some use cases and do some live demos. And after that, I'll share some other resources and do the Q&A in the end.
All right. And I'm here today to talk about MLB on Google Cloud. Our goal is to help move the game of baseball forward. It's how we at MLB can provide a better experience for our fans. Quick question before I start. Show of hands, who's heard of baseball? Keep them up. Who here has played baseball? Oh, I love that question. Makes me feel so good. Anyway, moving on. So for those of you who might not know about MLB, we have 30 clubs. We play 2,430 games per our regular season. And in 2023, we had a total game attendance of 70 million people and 172 million minutes watched on opening day, which is quite a bit. So I do have a quote I want to share from the Commissioner of Baseball, Rob Manfred. The partnership with Google Cloud provides us with technology that will drive us to be better. As big as we are, we knew we needed someone bigger to help us. And we thought Google Cloud was the best partner for us. So our relationship with Google started back in 2020. And now we have over 150 GKE clusters running 6,000-ish applications, 34 different internal business units, and Anthos across all of our major league parks. Haha. And our high-level observability architecture, just to set the stage, we have individual projects, 4 business units broken out, prod, non-prod, sandbox, that contain regional Kubernetes clusters, VM instances, Cloud SQL. If Google's made it, we probably have it somewhere in our environment. And moving into the observability suite, which is log analytics, monitoring, metrics, and alerting, which helps us centralize that information. We can use the metric scope to combine multiple projects into a single view. And for the cost analysis, we can join the billing data to this as well. So we have Looker Studio dashboards available, which make it all interactive and pretty. And now I'm going to hand it off to Joy to talk about observability analytics and billing.
Thank you, Frank. So I'm going to talk about cloud observability. So what is cloud observability? Cloud observability has 3 major components: cloud logging, cloud monitoring, and cloud trace. We also have advanced features such as SLO monitoring, uptime check, and synthetic monitoring. So here is an ecosystem of cloud observability. So telemetries from all GCP services are natively collected, such as logs, and more than 5,000 metrics are natively collected from the GCP services without any configuration. We also have logged logs and telemetries from external sources, such as generated by Ops Agent, OpenTelemetry, Google Managed Prometheus. These telemetries are stored in our highly performant and scalable storage. And these storage are also the storage that powers Google services such as Gmail and YouTube. And then you can take actions on these telemetries, such as creating an alert, set up a uptime check, and getting more insight with these telemetries. So I've covered what is the foundation of cloud observability. Now, let's talk about observability analytics. What is observability analytics? So observability analytics is derived from the foundation, from the telemetries that we already have. And it's powered by a BigQuery-based managed platform in a centralized way. So you can perform more advanced features, advanced use cases such as FinOps, SecOps, DevOps, AIOps, etc. And we take logs, metrics, traces, and metadata from your existing telemetries. You can also have your business metrics joined with them. And you can perform SQL in a centralized managed platform to get more insight. This is, in a nutshell, what observability analytics is. So here is the ecosystem of the observability analytics. So keep in mind that it's powered by the BigQuery managed storage, and on top of that is the telemetries that we have from cloud observability: logs, traces, metrics, metadata, your own business data. We can also integrate with billing data, which we'll talk about today, cloud asset inventory, and other GCP services, including your own business data. And in GCP, we provide charting, alerting, custom dashboard of capabilities. We also provided a UI for you to query, or you can use BigQuery as a UI. And we integrate with Looker, so we'll demo that later in the session. And here is a brief timeline for observability analytics. So cloud observability has a pretty long history, but observability analytics is relatively new. We introduced the logs analytics as the first pillar back in 2002, about like 2 years ago. After that, we introduced the alerting. So you're able to create an alert, a SQL-based alert on your observability data. And then we introduced the metrics and trace private preview very recently, last Q4. And we also GA'd charting. So now you can create a chart of your observability analytics data, and you can save them in a custom dashboard. The metrics is currently in private preview, and we're going to public preview later this year and GA later this year. So here is a brief look on how it looks in the Cloud Observability Console. So if you navigate to monitoring or logging and search for observability analytics or logs analytics, you'll be able to see your logs and metrics on the same UI. And here is a brief look how it looks. You can query them. You can save. You can query. You can save to a dashboard. So now, I'm going to pass it on to Rupa.
Thanks so much, Joy. And now I want to talk a little bit about Google Cloud Billing, otherwise known as FinOps. So what is our vision? Our vision is a world where all Google Cloud costs are visible and allocated, always optimized and properly managed. So what does that actually mean? This means that there's increased tag coverage, that there's increased granular cost support, that there's coverage of cost cuts, that there's recommendations that are available to you so that you can understand how much you can save, and that your costs are actually forecasted and anomalies are detected. This is our bold vision. So a little bit more about Google Cloud FinOps. You may say we're a Google Cloud Billing team. We say we're a FinOps team. Well, what is FinOps? FinOps is a practice of cost management and cost optimization. At Google Cloud, we actually have product pillars that are focused on each one of these areas. We have tools and features to ensure that you have coverage in each one of these FinOps areas. First and foremost, Inform, being able to understand and allocate all of your costs to power unit economics. You can also, with the Optimize pillar, ensure that you have the tools to estimate your costs, discover where you can save money, and establish efficient spend. And in the Operate pillar, we make sure that you have no cost surprises. And we do this with tools like budgeting, forecasting, and alerting to ensure that you are not surprised by your costs. So what do we offer? We offer 3 billing exports to BigQuery. You can scan this QR code to learn more about our exports and our documentation. You can enable all of these exports directly within the billing console within one click. Some interesting facts about our billing exports: we update our cost data up to 8 times a day, depending on the service. Cost data can sometimes mean terabytes of data, and with BigQuery's capabilities, you can query and store all of your cloud billing data. Fun fact, actually, within our FinOps team, internally within Google Cloud Billing, we use BigQuery ourselves to store this granular cost information and query it. We process billions of rows of data a day. So we have our 3 exports. Our first export is our standard billing export. This export offers basic information like costs, credits, usage, And SKUs, labels, projects, tags, etc. has all of your cost information that you are looking for to conduct cost analysis. Our detailed export is actually a superset of the standard export where you can find resource level costs and additional price fields to connect to the price export. We are constantly adding more support for services in our detailed export. We recently launched cloud storage bucket level costs in our detailed export. And our detailed export is actually what you can combine with what Joy mentioned, the metrics BigQuery export, to provide really granular insights for GKE, which Frank will talk about in a bit. And lastly, our pricing export. Our pricing export provides list price related information, your contractual pricing information, currencies, geographic taxonomies, etc. The primary challenges for our customers always still remain. How do we actually conduct cost allocation and conduct unit economics? In essence, what's my return on my cloud dollar? We have been focused on improving our data and tooling to support this by focusing on high quality, timely, granular cost data. Actually, you should tune into Sarah and Milan's talk tomorrow at 11:45 to learn about some more exciting updates in this arena. In the last year, we've increased our granular cost coverage by 20% with the releases of App Engine, Spanner, Firestore, BigQuery, Cloud Storage, and Bigtable. In the example you can see here, we're actually showing you what BigQuery costs, which is a little bit meta, but BigQuery costs look like before. Whereas before you can see on a SKU level basis what BigQuery costs were, with our detailed export, with the launch of this service, you can actually see, hey, what are my BigQuery job level costs? So with our granular costs that we've added into our detailed export with the service coverage, you can actually get those resource level costs and get granular into understanding how much you're spending. And at Google Cloud, we believe in open data. In January, we launched an exciting feature to support open billing standards. What is FOCUS? The FinOps Open Cost and Usage Specification, aka FOCUS, is a vendor-neutral and cloud-agnostic cloud schema that is a terminology for basic cost and usage dimensions across a few different vendors. And we know that we're not the only cloud provider out there. That's why we are continuing to pioneer open billing standards. Google Cloud is a founding member of the FinOps Foundation. We are the first cloud service provider to join the Open Billing Standards project. And what we provided here in this tool is actually a BigQuery view. We launched a BigQuery view that leverages the FOCUS standardized Google Cloud data in FOCUS standardized format so that you can actually see your detailed billing data and your pricing data in this BigQuery view. These are virtual tables, so you incur no additional charges for this if you're already using billing export. So with this export, you can actually see, or with this BigQuery view, you can actually see your data in an open format towards a FOCUS specification. And with that, I'm going to actually pass it to Frank to discuss use cases. And I'll start by asking Frank, what's your #1 goal?
Well, that's a loaded question. Anyway, my #1 goal is to make sure my finance team is happy. Yeah, I know. Oh, but in more serious, thank you. On a more serious note, it's getting deeper insights into our cloud footprint. The specific problem we're going to talk about today is around MLB's CI pipeline, specifically GitHub Actions, and it's the core of our CI platform. We build almost everything from this, and this is what resonated the most with me. We were able to take this third-party application, wrap it in the Observability Suite tooling, and now we have full visibility into this core service at MLB. So with the build pipeline in mind, let's start to unravel this metaphorical ball of yarn. So when you start running GKE at scale, the amount of data and metrics incoming can be, well, a little overwhelming. As shown here, they forgot to hide the laser pointer. So one tip is to understand the specific workload and dive into the why. With cloud metrics, we can do just that. Pull together the details of what the pods are doing and tie the information back to billing data to see the who. And the point I want to make specifically for our FinOps practitioners in the room, cost data in context is far more powerful than spend numbers alone. So we take the previous example a step further we layer on log analytics. So we will go into this in much more detail in the demo, something, trying to keep my slides down. So we've looked at logs. We all have. They fly by. It's a needle in a haystack. So with log analytics, which, by the way, is a free upgrade, seriously, you click the button, no extra cost, and now you have logs in BigQuery. So with log analytics and our metrics export, we can use BigQuery to join the data with all the power and functions of BigQuery. Logs and metrics. Now we've got context. I do want to make this point. We're using log analytics and parsing raw data, raw log data, creating insights on the application itself that don't exist out of the box. Now let's get to the fun part, the demo. Please hold while we get logged in and demo turned on. All right.
As a practitioner for MLB, let's say, I'd ask Frank, what are we looking at?
This particular dashboard is our GKE fleet dashboard. It's showing the clusters that we have enrolled in it right now, where we can see utilized, pod idle, and cluster idle at a high-level view over particular date ranges. And we also have another graph down here for CPU utilization with the core hours usage. So you can see, in this case, just how unoptimized these clusters might be.
It looks like the cluster idle is at 70%. How might we actually analyze that?
Yeah, so 70%, as I'm sure some of you may know, that's bad. And the goal is to make it more gooder. The technical term, we're at a technical conference. So anyway, in doing that, we can switch over to this dashboard and select our particular cluster. We're also able to drill in by namespace and by particular date range. In this case, we can see the cluster memory and the cluster CPU by these wonderful sunburst charts on the left. You can see at the cluster level, namespace level, and the pod level to see just what's taking up all the resources. And by namespace, you can drill down, in this case, our action runner system, and take a look at exactly what is being used in the requests. And in this particular case, it's the runners, strangely enough, taking all of the CPU usage, memory usage. And the graphs on the right are a quick overview of what the limits, request, and actual usage looks like. So we can see limits are running hot on this particular page. Cluster CPU, you will see the line spike over, and that is purely because there are several pods we don't have limits on, which we definitely need to address when I get back home. And moving into, we've got a view of the what, and now we get to the how with our utilization and optimization tab. Cluster core CPU utilization, used percentage is 10%. Yep, we see a pattern here. And we've got another visualization down here for cluster cores. You can see used and allocatable. And we also have this wonderful cost optimization opportunities chart on the right here.
Frank, I see you're the cluster owners here.
Yeah, that's what happens when you use live clusters for your demo, unfortunately. So yes, that generates a little more work for me. So now that we've talked about the GKE fleet itself, let's get to the interesting part. GitHub Actions runners and the reports.
There's a lot of going on, Frank.
Yes, there is. And this has a bunch of information packed into it. We've got overall build health on the left. We're able to see total builds, total unsuccessful, success rates, metrics for the previous 7 days, 30 days, and just how often and when those jobs ran, quick visually. And to the right, we've got cost summary, which allows us to see which particular organization is spending the most on used resources. In this particular case, we're just accounting for CPU and memory, but the option exists to keep expanding this deeper and deeper as you go.
I noticed that ticketing platform seems to have the highest cost here.
Yes, yes they do. And once again, if the cost numbers look weird, it's because of the date range in the upper right-hand corner I have selected. And we can take a look at ticketing platform by scrolling down to the other two graphs we have available. Build count by owner, in particular, is the interesting one. We can see ticketing platform is 5, 6, 7, 8th down in the total number of builds, and compared to the next highest in cost, baseball data, who is about half, and they're doing 4 or 5 times as many jobs.
So there's something going on there.
Yeah, that's definitely something we're going to look into, and I think that's just where we're going to go with the demo.
Yeah, I also noticed the cost breakdown here.
Yes, this cost breakdown chart was super neat. It's giving you a running total of your unallocated CPU and memory cost. The little bump there was a maintenance. And on the bottom, a stacked bar chart that lets you see the dark blue is our CPU, the light blue, teal, is our RAM, and the next biggest is the networking cost in pink.
Interesting. I saw there's peak and valleys in the networking cost. It feels like it's correlated to the builds, number of builds.
Yes, and we can look back here. We can see that we have traditional spikes throughout the day, and I am willing to bet that we can get that network utilization down even more by efficient builds and making sure people are pulling from local caches instead of, anyway, I digress.
So can we take a closer look at the ticketing platform?
Yes. We can switch to the owner level view. I do have it zoomed out at the moment, showing all owners, because I really, really like this bubble chart. It lets you see the average duration and build counts. In this particular case, we have a build running for 3,000 seconds, which is, oddly enough, a huge outlier. Once again, another point, live data, taking home, gotta fix it. So we can zoom in from here, selecting the owner of ticketing platform. We can take a look at their build health on the left in the bubble chart once again, and see that the PV core job in particular has the highest build duration, highest build count, and the highest average duration. And under cost summary,
Highest the cost.
that's where all the cost is. So we can keep diving and just get a look at what this particular organization is doing with the job executions over here. So this is vCPU hours and memory gigabyte hours in the dark blue and teal, and that's where most of the resources are going from there. Also a nice little failing count on the bottom here to see if it's a systemic problem across all builds or just one or two in particular.
That job's utilization looks very busy.
Yes. The job utilization, as I have it set up right now, it's sorting by average CPU. So the dark blue line here. And if we take a look at PV Core, we can see that its average CPU is less than 10%, but its max CPU is running anywhere from 95 to 101 in this particular case.
There must be something going on with the PV core.
Yeah. And it could be a laundry list of things. It could be as simple as a heavy build running for a short period of time. There are many optimization patterns you can put into a build, but this is Ops 101, so I'm going to move on. Now looking at the job itself. We're switching to the next page, job level view. And we've got the same report. We're bringing overall build health and cost around again. I don't have a job selected yet. We can see job executions for the particular organization and job efficiency metrics, which will be very fun when we get to that, which is right now. So now we've got ticketing platform and our particular job name. We can see total builds, all the top two are updating themselves, job execution with that scatter plot, average utilization by run, and yes, that does look weird. I would expect it to be all staggered in a particular spot, so another interesting data point for live clusters. Anyway, My favorite piece of this is the job efficiency and metrics. We're able to sort by build result, which are being pulled from the logs, and then overlay any Kubernetes metric we want. Right now we've got CPU request utilization and memory request utilization, but we could select any of these and the dashboard widget would update itself from there, letting you not have to leave this page to pull in other information. And with all of this just scratched the surface of what we were able to do with the observability suite with Google. And that will conclude the demo. We'll switch back to the slides. Awesome. Come on. So our dashboards, they let us see top down, bottom up. It's within the organization. It lets you provide insight for everyone from your developers to your C-suite and everyone in between. And to wrap it up, we're able to pull log statistics, correlate with system metrics, and tie back to spend, all in one place.
Thank you so much, Frank. I love your demo. All right. So as I mentioned earlier, observability analytics, the logs portion is G8, but metrics portion is currently in private preview. So to sign up, here is a sign up form. Once you sign it up, we'll send emails to you, and you will be able to use it, also enabling metrics to become available in observability analytics. And as I mentioned earlier, we're going to provide the templates that, similar templates that Frank demoed in the first use case, which is managing GKE cost. And here is the blog post with the templates that's similar to what Frank has shared today. And you can just follow the blog post and plug in your own data. And once you sign up for the private preview, we'll follow this blog post, you'll be able to do the similar thing. All right, so these are the related sessions to continue your journey. And now we're happy to take questions. Go back to right there. By the way, so the tech lead for this feature and the solution architects who built the templates happen to be in this room. If you don't mind, stand up, so they can take the questions as well.
I will say they have been a huge help and answered a lot of silly questions at weird hours of the night. My hours, not theirs.
Awesome. We'll keep this in the background and we'll take questions. Yeah?
Yes, please.
I noticed you had a lot more workloads than GKE clusters. How did you decide which ones to put on which clusters, and how do you map your owner dimension to those clusters?
Yeah, and to repeat the question, it's how did we design our GitHub Actions deployment, essentially, correct? Yeah, so we run centralized GitHub Actions, and we have it on a single cluster at the moment, and that is set to scale and unscale on a particular node pool. We've been playing with preemptible nodes, but it hasn't quite got there yet. But it's a single cluster, optimized nodes, and we spread them out. And why the idle was so high in particular was we have 3 or 4 warm nodes just sitting there waiting, so the people don't have, your end users don't have that 2-3 minute spin up time for a node.
Using like Kubernetes app labels or just the generic metrics that come with GKE?
Oh, for the metrics we're pulling out. Yeah, so the metrics we're pulling out is all from the metrics export, right from GKE's native default out of the box.
Yeah, I wanted to add to that. Like, there's nothing fancy. We're just using everything out of box and then pipe them into a BigQuery-based backed platform, and then join the data all together. And that's how the magic, like, it's simple, but the magic happens when we join everything.
Hello, nice presentation. What do you do for the network, like traffic, egress, all these things, or do you care?
So I am actually in charge of the networking inside the cloud as well. So we have been lucky that the particular nodes that we're using have not had bandwidth issues. It's something I am keeping an eye on around throughput in and out. But the nice part is with the spread of Google services that we're using, keeping it all inside GCP is helping us alleviate a lot of that bandwidth worry.
So you don't have any on-prem footprint anymore?
Oh, we do. We have Anthos in all of our ballparks. We have 2 or 3 data centers, and we have pipes into GCP, dedicated and interconnects. So we have observability across all of those in particular to make sure data coming in, going out. As we add new features in the park, getting them back to home base and shipping them off to the cloud is not going to break everything. And that's an actual concern around network traffic that we were having this year. So we have much closer eyes and alerting on it.
Cool, thank you.
I have a mic, so I'll talk. I was curious about how, who is making these dashboards at MLB? Is it like the DevOps team? Is it a specific business intelligence team? Basically, is this a tool that everyone can use and kind of gather around? And how do you decide when to spend time building these dashboards at MLB? Like, is there a product manager that says we need better insights into what's going on in GitHub Actions?
Yes, and around deciding who's doing what and why, I actually have MLB's lead of SRE in the front row. So I'm not putting her on the spot. I can't answer this. We typically have engaged with the SRE team to do any of the heavy lifting. But for these demos in particular, the first set was all stock standard. And the second set was me I spent more time on the BigQuery than I actually did on putting the widgets and overlays in. So not a good answer to your question, but it is whoever feels the most pressure. Yes, it's the party who is usually the most familiar, and that's where MLB's SRE team, they're tied into metrics monitoring and alerting. So they are typically the go-to, but if it's something that falls in my domain, I may spend time on it. I may have someone else work on it, and I'd go with the domain owner is the particular individual to reach out to.
Hey Frank, thanks. I had a question on the, how much influence does the analytics team have on things like recommendations to the competition committee about rule changes, such as the recent change from 18 to 15 seconds with runners on base? And could you talk a little bit about how that process works?
I actually have an answer for this. I have zero influence. But in all seriousness, I have zero influence.
Yeah, so first, great presentation, guys. But 2 questions, actually. First question is what did the level of effort look like to slice and dice the data to get it fit for purpose for these dashboards? And then the second question is what's the lag time on the dashboard?
Yeah, so slicing and dicing, the hardest part was remembering how to BigQuery with logs. And because every application puts out logs a little differently, it was improperly formatted JSON, so you had to get creative on how to cut and splice and pull it in to get what you were looking for. But after you got past the logs part, the metrics were easy. Look at the schema, pick what you need, pull it out, join them together, and you've got gravy. What was your second question?
Second question was, what's the lag time look like on those dashboards?
So the lifetime on the dashboards, it depends on how long you are retaining your logs via log analytics. And I'm going to let Joy answer how long metrics live for.
Yeah, that's a great question. So metrics, we have actually a retention period for most of the metrics for 2 years, and it's free for the time series data. Yeah. So yeah, and also in observability analytics, it's a 2-year retention.
Great, thanks.
So you have some costs that are things like ticketing. Do you track costs by baseball team or by club or by stadium?
Interesting question. So MLB and we are the baseball office of the commissioner and the technology and broadcast team. The clubs actually do their own thing and have an individual relationship with Google outside of us, where we don't directly impact them, but we do provide consulting, optimization, billing, and all of the good stuff that we can give at the enterprise level back to the individual clubs just for the sake of competitive advantage.
Question on multi-cloud. So we are getting multi-cloud. So have you explored the solution? Just ECP or even Azure or AWS, you can bring all the costs to BigQuery and do that. Do you have that kind of setup in your environment, multi-cloud environment?
So we don't at this point in time. We do have footprints in other clouds that I'm interested in bringing in, but I'm going to point to Rupa and the focus on the focus billing export, because that's going to simplify a ton of stuff when it comes to trying to join that aggregate billing data together. And if anybody's ever queried it, it takes a bit to get used to.
Yeah, definitely. So one of the items that I had previously touched on before was the open billing standards. One of the milestones that we are tracking towards is the GA of that focus specification that we're hoping for in the next couple months, hopefully. And with that, what you'd be able to do is actually export Google Cloud billing data and compare it directly with AWS and Azure with the specification in the format that is defined from the focus standard. So we believe that that's a great step forward to actually conduct your cost analysis across clouds. That is a major first step, especially since most of the cloud providers are a part of that working group, working together to figure out how might we actually normalize this data and provide the right specification that anybody can adapt to basically put their data in the right format. We also provide the BigQuery view where you can just do that automatically and then compare it. So we're taking steps in that direction. As we know, this is a huge challenge that customers have, and it's a big focus area of ours.
Okay, one more question is, you mentioned about log analytics metrics right through using, but does the solution support third-party?
Yeah, I can take that question. Yeah, so I think the question is that whether we're able to take the logs and metrics from other platforms to us. So the answer is yes, yeah.
We got one up here.
I'm curious, do you have a storage footprint, and how do you sort of join that data in with the usage data that you have here? Like GCS bucket data or anything like that, or even like the BigQuery data itself.
Gotcha. So are you talking in the scope of this or at MLB in general?
In MLB in general.
So we have a team dedicated to that who happens to also be in the room. Thank you very much, baseball data folks. And they are amazing. And BigQuery is truly the core of the data. Where we put it in, we use it. It's our primary data storage source. I can't speak to it any deeper than that, but we can definitely talk afterwards and get you some better answers. We've got one up front.
Rupa, you mentioned support in billing data for services. You didn't mention data flow. Any timeline for that?
Yeah, I think we can talk afterwards in terms of some of the services that we're looking to support. There is a backlog of service producers that we are talking to that we have made it quite far with in terms of scoping and commitment. And our goal is to tackle the top sort of 20 services by usage. We've made some great progress on that as well in the last 2 years. We've had almost a dozen services added, so there's more to come.
Hello. I think the question I have is about Cloud SQL and other services, but I guess the answer you just gave, right? So do you have any idea about Cloud SQL? And if I want to have like visibility on specific database instances, is that something on the pipeline for support on the export?
Yeah, so Cloud SQL instance level costs are supported in billing exports. We launched that last year.
Okay, perfect. Thank you.
Yeah, quick question over here. Do you do anything where you kind of marry the observability data with your performance metrics, with your fan engagement metrics, and sort of the ease of use of your platform and things along that line, with your product experience and your observability metrics?
Yes, yes, we are, in several different ways. In particular, I guess I'll preface this with our apps from the app stores are built in-house. So we do everything soup to nuts. And we're able to take all of that telemetry data, overlay it on statistics of the game that the baseball data team and all of the data from the ballparks, and marry them together and get these deeper levels of insight. And something that we are actively doing on the FinOps team is putting everybody's cost against the number of games per day, which is a very interesting metric. And you'd expect it to bounce up and down, but unfortunately it doesn't do that. So that's another conversation I get to have. FinOps opens so many doors. But in all seriousness, thank you for all that you do, Rupa, on the FinOps side and letting me complain at you and getting stuff moving. She's a huge help.
All right, if there's any questions, we'll be over here if anybody wants to chat or discuss any top of mind issues.
Thank you, everyone.
Thank you, everyone, for joining this session today.